How's it going, folks? Jack here with another reaction. So I've been recommended to check out a bit of a joke of a video. This one is a follow-up to the curse unit videos that we've seen before from Joseph Newton, and it has got to do with a C system, calories, middle C. That's the note, right? 240 hertz from like music. Funny enough, I was visiting my parents the other day, and we talked about like radio towers that they had in the city where they're living in that were sending in very low frequency. Oh, sorry, rather high frequency. And we ended up talking about the actual notes that would be used. So that's how I remember the middle C and the speed of light. I don't know how this person is going to be doing this, but Jan, hopefully I'm pronouncing the name correctly here. Let us dive into your joke.
I'd like to share a joke with you. It's a joke about systems of measurement, which I think is pretty funny, but before I tell it, I'm going to have to go over a few basic concepts. I'll try to make this quick. So there's this concept in metrology called coherence, where you can do math to stuff that you're measuring without needing to worry about converting the units. It's a pretty good property for a system of measurement to have. Like, okay, speed is just how far something goes divided by how long it takes, right? But, like, if you want to know how fast something went in miles per hour, and you know how far it went in feet and how long it took in minutes, just doing the division gives you the answer in feet per minute, and you have to do extra math to get it in the actual units you want. So the set of units you're using, the foot, minute, and mile per hour, don't form a coherent system of measurement. To make a system of measurement coherent, you just need to make sure that you have one standard unit for each fundamental quantity, and that all the quantities that can be derived from those are given units derived from those standard units. So, like, you can just decide that you always measure length in meters and always measure time in seconds, and then in a coherent system, you would also always measure velocity in meters per second. That way you can avoid all the extra math. And in the International System of Units, there's a whole bunch of units that are derived from the meter, kilogram, and second, the units of length, mass, and time. So, like, force is mass times acceleration, so it's measured in newtons, equal to kilogram meters per second squared. You don't need to use MKS, meter, kilogram, second units, of course. You could just as easily use a coherent set of FPS, foot, pound, second units, and measure length in feet, mass in avoirdupois pounds, time in seconds, and... Sorry, hold on, I had to...
It is pronounced correctly. That is avoirdupois. As a French speaker, yes. Avoirdupois, which literally means having some weight, is, you could say that, but, well, in English pronunciation, it is avoirdupois. I've encountered the unit before.
To look up how to say avoirdupois for this video, and, like, I've been saying it like avoirdupois in my head this whole time, because this is, like, the most French-looking word, so obviously it's going to be pronounced like that. But no, it's apparently usually avoirdupois, so I don't want to see anyone correcting me in the comments saying that I should be saying it the French way, because I checked and it is usually pronounced avoirdupois. Where was I? Right, so you can measure force in poundals, equal to pound-feet per second squared. There's even other coherent metric systems, like CGS, centimeter gram second units, where force is measured in dynes, gram centimeters per second squared.
We saw that one before.
All of these units, the newton, poundal, and dyne, are all defined the same way, just with different base units. Force is equal to mass times acceleration, and acceleration is just distance divided by time squared. So you could really make a valid unit of force out of whatever length, mass, and time units you want. You could even use the FFF, furlong-Furkin fortnight system, where force is measured in Furkin furlongs per fortnight squared. The FFF system is pretty silly, but it's not the joke. Here's the thing, that statement, force equals mass times acceleration, doesn't really mean that force has to be derived by multiplying mass by acceleration, right?
Okay, here we go.
You could just as easily say that mass equals force divided by acceleration. The poundal isn't actually the most common FPS unit of force. While a pound is usually used as a unit of mass, there's another unit that's also called a pound that's actually a unit of force.
Oh, yes, that's true. You get the slug out of this, if you follow his logic. Shooting replicas with my dad usually is an old English unit of measurement for like gravity that was usually employed with measurement of like projectiles. So yeah, a slug.
If something has a mass of 1 pound, then the gravitational force between it and the Earth is 1 pound of force. That's what it means for something to weigh 1 pound on Earth. It and the Earth are gravitationally pulled towards each other with 1 pound of force. Using this pound of force, you can then divide out the FPS unit of acceleration, feet per second squared, and get a unit of mass called a slug, which is about 14.6 kilograms, or 32 pounds of mass. Heck, in the standard MKS system, acceleration is measured in meters per second squared, but since acceleration equals force divided by mass, we could just as easily measure acceleration in newtons per kilogram instead. And since it's a coherent system of units, we know that 1 Newton per kilogram precisely equals 1 meter per second squared. And you know what? You could go even further, because over in the metric system, you have kilograms as a unit of mass, and over in the American system, you have pounds as a unit of mass, but also separately pounds as a unit of force. So you could absolutely measure acceleration in pounds per kilogram. I have no idea why you would want to measure acceleration in pounds per kilogram, but you can. And that idea got me thinking. What other base quantities could you use to form a coherent system of measurement? Okay, now here's the joke. This is my new idea for a fundamentally different kind of coherent system of measurement, the CCC system.
I feel like I'm just going towards the entire thing being like Ryan Reynolds in Harold and Kumar, the movie there, where he's wearing that surgeon gown and going like, but why? Why are you doing this?
The 3 fundamental units that the majority of the CCC units are derived from are not length, mass, and time. In fact, none of those quantities are given their own base units at all. First is the standard unit of velocity, the speed of light. The speed of light, commonly abbreviated to c, is a fundamental constant of the universe. It's the fastest possible velocity allowed by the laws of physics. In the CCC system, rather than representing velocity as length divided by time, it's represented far more elegantly as some multiple, or more accurately, some portion of c. The speed of light is equal to 299,792,458 meters per second.
Or 6.
That's not an approximation, by the way. The speed of light is used in the standard definition of the meter, so by definition, that is the exact value of the speed of light in meters per second. Oh, and since US customary units are all defined according to their relationship to SI units, I can also say that the speed of light is equal to 670,616,629
miles per hour.
539 over 1,397 miles.
No, this is so nasty to look at. I can't.
Per hour. The CCC system doesn't have a unit of mass, but that's fine because mass is famously equal to energy divided by the speed of light squared. The speed of light is a fundamental unit in the CCC system, so if we just add in a unit of energy, we can use that to get a unit of mass. The unit of energy I went with is the calorie, since it's a unit of energy that people are generally pretty familiar with.
My brother in math. Why? I'm sorry, why? See, okay, look at this, okay? If we go just a step back. Okay, yeah, that gives us kilograms, but that's absurdly small. Here's an example, okay? Always when I'm editing, I have a form of snack. Usually it's fruit, this time it's nuts, okay? This is a nut mix. There's 350 grams in here. And of course there are calories in the back, 637 per 100 grams of it. Now, the thing about calories, as he basically wrote here before, is the amount of energy that is required to raise the temperature of something 1 degree. Now, calories are equal, I think 1 calorie in joules is 4.18 joules, which of course you can rewrite as kilograms per meter squared over second squared, which again, since we're talking about the speed of light here, you have already 2 of the components in there, being the mass squared and the second squared. Remove that, you have kilograms, which of course the speed of light is times 10 to the 8th, which if you have to convert that from grams, from this one, or kilograms, you end up having something that's double that, so 300, sorry, to rephrase, you will have the mass on this one being written not as 350 grams, but rather 350 times 10 to the minus 14th grams. Who wants to look at that? I'm just asking.
of mass. The unit of energy I went with is the calorie, since it's a unit of energy that people are generally pretty familiar with. A calorie is the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. This definition isn't very precise because it depends on a lot of different factors. So the standard definition actually used for the calorie is to say that it's equal to exactly 4.184 joules. That is 4.184 kilograms square meters per second squared. And again, because E equals mc squared, you can divide out this unit of energy by the speed of light squared and get a unit of mass out of it, the calorie per speed of light squared. Since the speed of light is very fast, a calorie per speed of light squared is a very tiny amount of mass. It's equal to about 46.55 femtograms, a femtogram being a unit generally used for things the size of bacteria.
Yes.
There are 1 billion femtograms in a kilogram. Of course, no system of measurement is complete without a unit of length. It makes sense to derive a unit of length from the speed of light. You can do this by multiplying it by some unit of time. For example, the speed of light times 1 year is a unit of length called a light year. We could do that, but that's kind of boring. Instead, we can generate the unit of length by dividing the speed of light by a unit of frequency. That unit of frequency being our third fundamental base unit.
That's where little c comes.
I chose is middle C, a pitch found in some of the most common scales used in Western music. Middle C
piano.
is a generally agreed medium pitch, around the middle of a piano's range. The exact value of middle C is different depending on which tuning system
240 to
you use,
280
but it's most commonly
hertz.
tuned to around 262 hertz, cycles per second. Since we're using this as a unit of measurement, we need to pick one precise value, and it makes sense to just use the most common standard tuning system, where middle C is equal to exactly 220 times the fourth root of 2 cycles per second.
Assuming a minor 4 is tuned to 440 hertz and that the 12 tones equal temperature is why am I getting triggered by this? It's funny, but it's like to an excessive degree. Like I ended up in a rabbit hole recently trying to figure out the whole cycle of days because I needed to explain something to a friend, which I might actually turn into a video about why the days are called what they are, which had to deal with, if we have to go all the way down to the basics, with the sexagesimal system.
What?
Yes, I pronounced that word correctly. There's no other way to pronounce it and not make it sound sort of phallic or dirty. Sexagesimal system, a system of 6, right? Just like the trits system. Not tits, but trits, where you always are dealing with trees. But that was something with like the old Sumerians and later on the Babylonians who were counting with the hands, but also the knuckles, which ends up with having like a total of, 12 times 5, giving them 60. Not 6, sorry, but 60 system. And so, I ended up in a rabbit hole of how everything was divided by 60, and kind of funny, okay? I get that. But it being introduced to something that is not quite looking as logical to me is a little bit unnerving.
I don't want to get into different tuning systems here, but if you want to know why it's tuned to an irrational number of cycles per second, Minute Physics has a pretty good video that explains what the deal is with the equal temperament tuning system. If you want to get more into the music theory stuff of it, there's some good videos from 12 Tone and Adam Neely that someone watching this video who is interested in the music theory of different tuning systems has almost certainly already seen. Anyway, using middle C as our standard unit of frequency and the speed of light as our standard unit of velocity, we can generate a unit of length, speeds of light per middle C. Once again, the speed of light is very fast, and middle C is like a middle frequency, so a speed of light per middle C is a very long distance, equal to...
Let me move my head a bit.
Around 1.146 million meters, or like 712 miles. So with our units of velocity, energy,
oh
and
my
frequency...
days! Oh my days! No! The SI conversion, just barely making it through, and then we go to the US customary. No, we give up. We literally give up.
Now generated units of length and mass, which means the CCC system is now just as capable as the MKS, CGS, and FPS systems. Well, almost. We do still need a unit of time, but time is just the inverse of frequency. Our unit of time
One
is
over.
per middle C, which is like, what, 0.004 seconds? Anyway, now we can do some fun stuff. Let's pick a bunch of quantities and derive some units for them. I think the easiest one to start with is the unit of power, which means power. Power is equal to energy over time, which means it's equal to energy times frequency. So in the CCC system, power is naturally measured in middle C calories. 1 middle C calorie is about 1.1 kilowatts, or 1.5 horsepower. I think this is the first derived unit in the CCC system that's actually a convenient size, probably just because this definition doesn't involve the speed of light anywhere. Power is equal to energy over time, but it's also equal to force times velocity. That naturally means that in the CCC system, force is measured in middle C calories per speed of light. That's about 3.7 micronewtons. Oh, and now that we have a unit of force, we can finally figure out what this system's equivalent of newtons per kilogram is. Somewhat expectedly, the unit of acceleration is expressed as frequency times velocity, which is really just another way of saying velocity over time. There's also some pretty obvious units for area and volume you get just by squaring and cubing the speed of light per middle C. And since this stuff is exponential, it gets pretty huge pretty quick. The unit of volume is more than the total volume of the Earth's oceans. And that means anything that's usually expressed as something per volume is going to have a unit that's comically small. Like, let's take density. The unit you end up with is this, which is about 3 times 10 to the minus 35 kilograms per meter cubed. Oh, and using that unit of area, we can generate a unit of pressure, because pressure is force divided by area. The thing we get is about 2.8 attopascals. One thing that's interesting about these units of density and pressure is that they show a somewhat non-trivial restatement of E equals mc squared.
It does. It does. It actually does.
Pressure is equal to density times the speed of light squared. Anyway, while there is more you can do with these base units, you can't do everything. There are some things you can't do with just 3 C's. The SI has units for 7 different fundamental physical quantities, so if we want this to have the same capability as SI...
resistance, conductivity. Once again, the thing that always cracks up as soon as you start dealing with electrodynamics, everything falls apart. As if it wasn't already too complicated before, but once you start involving the electrons in there, good luck. And of course the chemistry.
We'll need to extend it into the 7 C's. I'm not going to go too deep into the 7 C's, mostly because they don't actually add that much to the aesthetic comedy I was going for with this system. I will define them here, though. For a couple of the SI quantities, there's just already common units that start with C, so temperature is in degrees Celsius, and
coulombs,
is in candles,
yes,
basic stuff.
Okay.
We're still missing a lot of units for electric stuff, so we can add in the SI unit of charge, the coulomb, which is 1 ampere times 1 second. We can then use the coulomb and the other CCC units to get units for all your favorite electrical quantities. Multiplying the coulomb by middle C, we get a unit of current equal to 262 amps. Voltage is equal to energy divided by charge, so in the 7C system it's measured in calories per coulomb, which are 4 volts. You can divide charge by voltage to get capacitance, which gets you square coulombs per calorie, around 239 millifarads. There's also resistance, which is voltage divided by current, giving you calories per middle C coulomb squared, equal to about 0.016 ohms. And of course you can't have resistance without conductance, so the unit of conductance is just the reciprocal of the unit of resistance, so it's 62.5 Siemens. Oh, fun fact, the SI unit of conductance, the Siemens, is sometimes called a mho instead, which is ohm backwards, and I am 100% positive that the only reason anyone calls it that is so they don't have to call it a Siemens.
You bet, because you always have to clarify that you're not saying Siemens, but Siemens. Putting pressure on the inflection is not always your priority.
Anyway, all that's left from the 7 SI units is a unit of amount of substance, which I don't think is entirely necessary. A mole isn't really a unit, it's just a number. So let's say that the 7C unit...
Yeah. Base Dracula.
Unit of amount of substance is just 100. Actually, having 100 helps a lot for all those units that are comically wrong sizes. Instead of using speeds of light per middle C as the unit of length, we could instead use speeds of light per million middle C.
Oh,
and by the way, the symbol I'm using for 100 here is the Roman numeral 100, not to be confused with the symbol for the coulomb, which is a sans serif capital letter C. I don't know how to end this video.
This was madness. This is how it feels to chew 7 gums. It's beyond stimulating your senses. You will unlock something new in your brain. 100% of your abilities. Now, the wild thing is that if you were to be put in like late 17 or 1800s, in between those years, was a respectable scientist and proposed this as being a new unit of measurement, like a new standard, they would have hopped on it. Like, if the CGS system was accepted, then this one could just as well be. But I'll be damned. Guys, thank you so much for this recommendation. That was a highly requested one from the previous video. This was fun. And as always, please do make sure to go and subscribe to Jan here. Of course, if you like the video, hit that like button. And I wish you all to have a wonderful day. Stay learning. See you guys in the next one. Bye.
My appetite. Don't leave me